Hi, I'm Kyle Miller, Enterprise Solutions Engineer at DJI, and for today's topic, let's talk about the methods of terrain following using DJI products. But first, let's define a couple of acronyms to help us better understand our altitude and our surroundings. When talking about drones' altitude, the most common terms are AGL and ASL. AGL, or above ground level, is how high off the ground the drone is. ASL stands for above sea level, or the altitude above the mean sea level on Earth. When defining the surface of a ground, we typically reference a DSM. A DSM, or a digital surface model, can be an elevation map of your surroundings. This helps us provide the base for terrain following missions. Next, let's talk about why terrain following is so important for mapping projects. Many sites have very large elevation changes, so planning a flight based solely on the height above the home location can cause inaccurate or insufficient overlap, or even cause the drone to fly into the object or into the ground. Also, with varying elevation changes, the ground sampling distance will be variable across the site, which results in variable accuracy. To implement terrain following on DJI Enterprise drones, there are three options to use depending on your flight needs. First, the most simple tool is real-time terrain following. This function utilizes the obstacle avoidance sensors to accurately understand the drone's altitude above ground, no internet connection required. To enable, just toggle on under the terrain follow option and choose real-time follow. The benefits are no DSM of the site is required before flight, and no connectivity to the internet is needed to pull that DSM. Currently, this option is only available on the Mavic 3 Enterprise series drones. There are a couple key points on real-time terrain following that you'll need to take note of. First, real-time terrain following currently supports flights from 80 to 200 meters. If flying over 200 meters, it is recommended to use the new in-app feature to download the global geoid file. But flights below 80 meters, it is recommended to import a high-precision DSM file which can be generated by DJI Terra after one flight mission. Secondly, the vision systems cannot recognize very thin objects such as power lines, so the drone cannot follow such objects. Additionally, this is not suitable for flights above water, as the live terrain feature will not be able to generate an accurate DSM. It's also not suitable when the terrain slope is greater than 75 degrees, and it's not suitable when the light is insufficient. The second option for terrain following is by using the download from internet option when importing a DSM. This pulls the DSM from the internet to use instead of requiring your own DSM of the site. This pulls a DSM from the internet to use instead of requiring your own DSM of the site. To enable, toggle the terrain follow feature on and select DSM follow. Select your DSM file and tap on the plus button in the upper right. Select download from internet and pull the DSM from the cloud. Our source for our DSM is from Aster G-DEM V3 with a resolution of 30 meters. Some advantages to this tool is that no DSM is required of the site before flight, and you can fly much lower than real-time terrain follow. Some disadvantages are the low resolution of DSM at 30 meters and the inaccuracy and age of that DSM. The final option is the traditional import of a digital surface model into the Pilot 2 app. The site will need to be surveyed prior, and the surface model from that site will need to be loaded into a micro SD card and inserted into the controller. Toggle the terrain follow feature on and select the DSM follow. Select the DSM file and tap on the plus button in the upper right. Select choose a file for the DSM, then select the DSM file in a TIFF file format from the micro SD card and watch the flight plan adjust for elevation changes. Some key points on your DSM file: make sure that it's 20 megabytes or smaller and has a spatial resolution of less than 10 meters. Utilize WGS84 or EPSG code 4326 for coordinate reference system. Vertical datum for elevation data should be ellipsoidal. This mode, while tedious, is the most accurate way of terrain follow. This also allows you to fly much lower than real-time terrain following. One additional note, if the goal is a waypoint mission instead of a mapping mission, you can plan the waypoint mission on FlightHub 2 and adjust the waypoints to the terrain to keep the same elevation off the ground. Thanks for watching. Subscribe to our YouTube channel to learn more about commercial drone applications, best practices, and user stories. If you like this video or if you have any suggestions, make sure to drop a comment in the comment section below.